This video is on solving by factoring. We're going to be solving by factoring the quadratic equation after it is in standard form, and then we're going to use the zero product property to figure out what values of x will make the equation equal to 0. So these examples we're going to solve by factoring. Our first example is 3x squared minus 20x minus 7 equals to 0. It is already equal to 0, and we have it in standard form of 3x squared negative 20x minus 7, so this is in standard form. First thing we need to do when we are factoring is determine what our GCF is. GCF, our smallest number is 3, so 20 cannot be divided by 3, and then after that would be a 1 times 3, so everything is divisible by 1, so our GCF is just 1. We do not have to do anything with that, so then we go into determining how to factor this further. There are 3 terms, so we would use MACAB. MACAB, we need to know our A, B, and C. So A is equal to a positive 3, B is equal to the negative 20, and C is equal to that negative 7. So when we go to our MACAB, put it over here, MACAB. Our MAC would be 3 times negative 7, which is negative 21, and our AB would be negative 20. We list out the values that will multiply it to 21, so that's 1 and 21. 2 does not work, 3 and 7, 4 does not work, 5 does not work, 6 does not work, and then 7 we come back to 3. So then we look to see which ones will give us the 20. So again, I did not use any signs yet because I will focus on the signs to make my negative 20. So 1 and 21 can give us a 20, 3 and 7 cannot. So I'm going to cross out the 3 and 7. 1 and 21 can give us a negative 20 if we subtract the 21 but have a positive 1. So now we need to make sure that 1 minus 21 will give us negative 20. And 1 times negative 21 gives us the negative 21. So this is our MACAB. Now we want to determine if we need to use the box. Since A is equal to 3, we must use the box. If A was equal to 1, we would not have to use the box. We could go straight into our factors. So I'm going to write out my box over here. And inside this box, I go to my standard form. The first box will have this 3x squared. And the last box will have the negative 7. Then in the other 2 boxes, I use the MACAB. I have a positive 1x, because I have to use the same letter. Then I have a negative 21x in the other box. So now we use our rows and columns and just find the common factor of each row and each column. So in this first row, the first sign is positive. The smallest number is 1, and so that has to be the common factor. And they both have an x in it, and the smallest amount of x's is just 1x. So I can pull out 1x to the outside. The next row, my first sign is negative. The smallest number is 7. 21 can be divided by 7, so we're going to have 7 out here. And they do not both have an x, so I cannot pull an x out. Then we're going to go to the column. The first sign is positive, so I'm going to have a positive. The smallest number is 3. 21 can be divided by 3, so we can pull out a 3. They both have an x. The smallest amount of x's is that 1x there, so I can pull out 1x. The next column, our first sign is positive. Our smallest number is 1, so that will be a 1. And they do not both have an x, so I cannot pull out an x. So now we just write this as our factors. Our GCF is 1, so we don't have to put anything on the outside. We're going to have that 3x plus 1 in parentheses times that x minus 7 in parentheses, but it still needs to be equal to 0 because all we've done is rewritten this quadratic into a different expression. It's the exact same equation, just written differently, so that we could use the zero product property. So now we look for the expressions that have variables in it. So this first expression, 3x plus 1, has a variable. We set that expression equal to 0. The next expression, x minus 7, also has a variable, so we set that one equal to 0. And now we solve for those variable x's. So on this first one, we're going to subtract the 1. We'll have 3x equals negative 1. Then we're going to divide by 3 to get x alone. So our x value will equal to negative 1 over 3. That's one answer. Then on the second one, we're going to add 7 to the other side. We'll have x is equal to a positive 7. X is alone, so our other answer is x equals to 7. These are our two solutions of x equals negative 1/3 and x equals 7. These are the two values. These are our two x-intercepts. So if we were to write them as a coordinate, it would be 7, 0 and negative 1/3, 0. This is where the quadratic, the parabola, is going to cross the x-axis. That's what we're looking for, is the solutions, the x-intercepts, the zeros, the roots. On this next example, x squared plus 7x equals 18. This is not in standard form because it needs to be equal to 0. So our first thing that we need to do is make sure this gets put into standard form. We have an x squared, we have a 7x, but our 18 is on the wrong side. We need to subtract the 18 to make it become x squared plus 7x minus 18 is equal to 0. Now we need to try and factor this. Our first step is our GCF. So I'm going to write out GCF. Our smallest number is the 1 on that x squared, so our GCF has to be a 1 because 1 can go into everything. Then all three terms do not have an x, so our GCF is just 1. Now we go into, there are three terms, we go into our MACAB. Our A value is 1 from our standard form, B is 7, and C is negative 18, because again you have to use it from the standard form. So MACAB, I'm going to do the half box. MAC will go up top, so 1 times negative 18 is negative 18. AB will go on the side, so that's 7. We list out the values that will multiply to 18. So I'm going to start with 1 and 18, 2 and 9, 3 and 6, 4 does not work, 5 does not work, and then 6 just repeats. Then we want to see which ones will give us a 7. So 1 and 18 cannot give us a 7. 2 and 9 can. 3 and 6 cannot. So 2 and 9 will give us a 7 if we have 9 minus 2. So we'd have a negative 2 and a positive 9. Now we need to make sure it max correctly. So negative 2 times a positive 9 will give us a negative 18. And 9 minus 2 gives us 7. So this is our MACAB. Now since we're using MACAB, we look to see if we need to use the box. A is equal to 1. Therefore, we do not have to use the box. No box. That means we can go straight into our factors. We go straight into our factors. That means we can take two sets of parentheses and set them equal to 0. Inside both of these, we're going to have just a 1x in both of these. And then we're going to take from our MACAB, we have a negative 2, so we're going to put x minus 2. Then we have a positive 9, so that goes into the second one, positive 9. We have now factored this, so we need to solve. We need to finish this by solving. We take each expression that has a variable and set it equal to 0. So our GCF was 1, so there's nothing on the outside. Our first expression is x minus 2, that has a variable. We have x minus 2 is equal to 0. Our second expression of x plus 9 has a variable. So x plus 9 is equal to 0. And now we solve for the values of x. So for this one, I need to add 2 to both sides. We get x is equal to positive 2. X is alone, so x is equal to 2. On the second one, we subtract 9. We'll end up having x is equal to a negative 9. 0 minus 9 is negative 9. X is alone, so our answer is x equals negative 9. So again, we just found the x-intercepts. So our parabola would cross at the x value of 2 and the x value of negative 9. So if we were to say these as x-intercepts, this would be 2, 0, and negative 9, 0. These are our roots, our solutions, our zeros, our x-intercepts. We have just solved for this quadratic by factoring.